Hi, Elena. This is Allison Buelson, and I'm recording an answer, I hope, and I think, to your physics questions. It's nice to be in contact with you again, and I hope you're enjoying college. So this is the question as I understand it. This is a two-body problem, and one of the two bodies is on an inclined plane. The bodies are S1 and S2, so masses, boxes, whatever you want to call them. The angle of inclination is alpha. The masses are M1 and M2. The plane is frictionless. The rope is massless and non-stretchy. And I love that word, inextensible. I don't think I've ever used that word before. It looks like you and or your TA are using a Z1 as an indication of your positive direction coordinate axis. You are considering only an inertial frame of reference, which really just means this frame of reference is not accelerating with respect to the surface of the Earth, right? It's a non-accelerating frame of reference. That's kind of, I mean, for mechanics, we kind of have to consider that all the time. And the problem is asking you to find, oh, did I say already a massless and presumably frictionless pulley, right? So for your original problem, we are ignoring any rotational issues inherent in the use of a pulley. So we're finding the acceleration of the blocks, and S1 and S2 will have the same acceleration since they're connected by this inextensible rope. And then we're also finding the tension in the string connecting the two blocks. Blocks, masses, whatever you want to call them. Blocks works for me. Okay. So your TA does have some interesting notation, as I mentioned. And as soon as I showed this picture to my husband, and you might remember my husband and I both were in graduate school together in physics, he said something like, this guy sure looks like he's trying to, I forgot what he said exactly, but basically trying to impress himself or trying to impress whoever's watching. He's definitely using notation that's not aimed at helping us understand. He's using very formal notation. Maybe that's required, I don't know. He's using unit vector notation. And I can also see that the blackboard is not completely erased, so it's hard at a glance to see exactly what he's written because there's a shadow of stuff underneath it. So, I mean, TAs are TAs, and you probably can't choose your TA. I don't know. And, you know, physics is physics, and what are you going to do? Okay, so let's get into the solution. Maybe what I'll do is show you the solution in my own notation, and then we can talk about how my notation varies between mine and his. I'm having a tough time reading. So in the first bullet point, he says reference frame inertial. Fine, we already talked about that. The second bullet point is the free body diagrams. Sorry, that's the bell for going to lunch, so you'll probably hear some background noise for a minute. So the second bullet point is the free body diagram for each of the bodies. I can't quite read what the third bullet point says. He says the system is something S2, comma, mass M2. I just can't read what that says. And then the fourth bullet point seems to say system, something S1, comma, mass 1. I mean, what he's actually doing in those bullet points is applying Newton's second law. And he's using unit vector notation to indicate the direction of, let's see, he's using unit vector notation to indicate the direction of those vectors because, of course, Newton's second law uses or refers to acceleration and force, which are both vector quantities. And then to the right of those bullet points, he has a line on the board, a short line on the board, a vertical line, and it looks like he's indicating the solution to the combined Newton's second law equations. Man, that notation is awfully hard to read. Is it, maybe you can reply to me by email, is that a J? Is he saying M2G vector equals M2G J hat? J2 hat? Darn it, what is this? And then, of course, in his solution to the Newton's second law problem, to the Newton's second law equation, he's using the double dots to indicate second derivative. So instead of saying acceleration in, let's say, the x direction or whatever, or the z. Oh, those are z's, right? No, that's not a z, because g's not in the z direction. I'm confused looking at his notation. But in any case, instead of saying acceleration in the x direction, he's saying the second derivative of position, right? Those are equivalent. Gosh, okay. So I'm not sure how long of a video I can actually post. So I'm going to stop here and post this, and then I'm going to say, can you write back to my questions about what, is that a Z or a J? I can't tell. Okay, I wonder if this guy has ever stood back and looked at his own handwriting. I don't want to be too critical, but holy cow, man. Okay, and I look forward to our continued interaction, and it's a pleasure to hear from you.